Haha! You thought you could escape me, but I am still here in spirit. Now, I didn't want you guys to not have what you needed. So, here I am virtually, and I'm going to teach you about how to actually use this periodic table here. So we're going to label a couple of things and talk about a few of the pieces that are here. So first of all, if you notice, if we go across, we've got several different columns going straight down. So these columns are simply known as the groups. And there are 18 of them, and they're really conveniently labeled as group 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we got all these groups right across the top. And the periodic table acts a lot like a grid where you have the two axes. So across the top, all of those labels are our groups. And then down the side, we have what is called a period. And there are 1, 2, 3, 4, 5, 6, 7 rows, and therefore 7 periods. So what you get right there. So 18 groups, 7 periods. We go up the groups as we travel from left to right, and we go up the periods as we travel from top to bottom. And these all mean things for what these elements look like. And that's the beauty of Dmitri Mendelev's table, is that even when he was missing pieces in here, because he was able to look at a lot of the properties that existed in the found elements, he was able to go, I think there's got to be a few gaps in here. So we can leave an empty space here. We can leave an empty space here. And sure enough, we were then later able to fill in those gaps and figure out where those missing pieces are just by using this grid. All right, so I notice that I have a little key down here. And this key is going to go into the elements that are metals, non-metals, or metalloids. So obviously, if we could break down everything into two groups, like, well, either something's a metal or it's not a metal. But there's some things that kind of sort of act a little bit like metals. So let's start, though, with the non-metals. So I am going to color code all of our non-metals in a light green. Hydrogen, which is our simplest of all the elements, that is a gas, typically found as a gas. Our simplest little element. He's our only little non-metal hanging out over here on the left-hand side. Now on this side, now we've got helium, which is also a gas, and therefore a non-metal. And all of here, carbon, which was in, some of you guys drew diamonds. Carbon is part of graphite and pencil lead. Nitrogen makes up most of the gas in our atmosphere. Oxygen, big fan of oxygen, being able to breathe. Fluorine is also a non-metal. Neon, used in signs, neon signs. Then I'm going to pop down here. We got phosphorus, sulfur, which is what gives eggs its rotten smell. Phosphorus goes in your bones. Chlorine, which is, of course, the same type of chlorine that's a part of your pool cleaner. Notice underneath chlorine is bromine. Anybody with a hot tub, you might be familiar with using bromine. Then we've got iodine. Xenon, even though it's pronounced with or spelled with the letter X, and radon. So these are all of our non-metals. A little bit of a pattern here. Then we can do our metals, and I'm going to mark these in yellow. There's a lot of metals. There's a lot of metals. So what we're going to do is we're going to shade everything except shade here. Tin is good. Bismuth. Livermorium. And these ones are kind of, sort of unknown. We're not quite sure what the deal is. But all of these, if you want to be way nearer than me, have at it. You get to keep these forever, or at least for the whole unit. Now, a lot of you noticed when you were looking for elements with different symbols, a lot of you noticed that it was kind of hard to find like 78, because we're going across the 37, 38, 39, 40, da 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 da. We get to 54, 55, 56, 72. Weird, huh? Well, that's because the lactanides, and then on the next row in period 7, the actinides, it would have added a lot to our table, which would have caused everything here to shift way over, and then we would have had to take this whole section and insert it. So instead what they did, the same way that you might use a caret in English class to insert another word because you forgot to put a word in there, that's pretty much what we're doing here. So all of these lactanides are going to be numbers 57 through 71, and the actinides are down here. That's going to be 89 through 103. These also are part of the metals. So that just leaves one little piece. And that's, I'm going to use this light blue for this, that's our metalloids. So metalloids, they're kind of like metals, but also kind of sort of not like metals. And that gives them some really cool properties, and we'll get into those more a little later. But boron is one. Silicon, not to be confused with silicone. Silicone is what is a type of plastic that often gets used in like, implants if someone's having a reconstructive surgery. But silicon is a semiconductor used in a lot of electronics. So you might have heard of Silicon Valley before, which was a time when IBM was huge and we had computers and technology booming, particularly in this area. So a way to remember which ones our metalloids are is if you underline boron here and we just draw a little staircase, anything that's touching that staircase, until we get to the really weird wacky ones on the bottom, but anything that's touching that staircase is a metalloid, with the exception of aluminum, which I'm pretty sure enough of us have had experiences with that we know that aluminum is in fact a metal. But this is your periodic table. I'm going to do the first couple of things on the flip side as well. So we looked at these groups, and recall that the groups, oh good, I can hold it like this. Recall that the groups go across the top from left to right. So group 1 elements, and don't write too big because we are going to add a little bit more information going forward, but group 1 elements, these are what are known as our alkali metals. Everything in group 1, with the exception of hydrogen. Hydrogen is not an alkali metal because it is, of course, a nonmetal. But starting with lithium, sodium, and going down, those are our alkali metals. Group 2 contains our alkaline earth metals. So still metals, a little bit different from these, and we'll talk more about these properties when we get to the table below here going forward. Groups 3 to 12, so this entire section right here, that's that whole block, and that also includes those lanthanides and actinides. It includes all of those. Those are what are known as our transition metals. We're transitioning from having super metallic properties over to the things that are less metallic. So we're transitioning. Then we get super creative with the names for the rest. So number 13, since it starts with boron, this is just called the boron group. Really creative. Then we get to group 14. Also super creative name. Since it starts with carbon, it's called the carbon group. Nailed it. Then we get to group 15 over here. And this one, I bet you can, I don't know, maybe you can't. I don't know. Maybe. Yeah, you're right. It is the nitrogen group. So there's the nitrogen group. And if you haven't figured out the pattern yet, yes, number 16 is in fact the oxygen group. And then group 17, I gotcha. It is not the fluorine group. These ones are called halogens. And we'll talk about halogens. They're very cool. Fluorine's an interesting friend. We'll talk about him more later. And then group 18, these are the noble gases. And this contains all things that are gases at standard temperature and pressure, with the exception of hydrogen, who does not get to be a noble gas, just gets to be a regular gas, I suppose. What does noble gas mean? Great question. We will get there soon. But groups are arranged from top to bottom due to all members having similar physical and chemical properties. This table is not a mistake. It was designed so that we could best understand how these elements behave, how the atoms of these elements behave, and make some serious predictions about how, when they combine, they're going to form bonds and create other molecules, and essentially be alchemists and create all of the things that make up our world, because everything on this table is all that exists in the known universe. So everything that you encounter, everything inside you, everything that you have touched, tasted, smelled, is because of combinations of the things right here on this paper. All right, I look forward to being back in class. I'll talk to you guys soon.